All right.
I got the crucible one he told us. He even gave us an example. He gave us one of them. You can take open notes. I don't take them. Neither do I.
All right, we're gonna finish up this lesson. You got a pre-quiz due tomorrow. It is up. Give this question a shot. Thumbs up when you got something. Have a conversation.
Well, I was already at the gravity. Kinetic energy is what?
Yeah, this is friction. Work done by friction, work done by gravity, work done by normal force.
Yeah, so just oh, it is. It's just not fair. I just, you know what I mean? No, I know. No. Because like you know how gravity is like split off from it. Yeah. I feel like it means like it's that's what we said.
What do you say?
B.
Okay. So here's your free body diagram. Okay. So we're moving down the ramp. So friction is doing negative work, acting in the opposite direction of motion. Gravity, specifically your force of gravity in the x direction, is doing positive work, acting in the same direction of motion. Normal force is acting perpendicular, so no work. To answer this question, what's the sign of network, you cannot determine because I did not give you values of these. You can't determine it from this point of view. But because you know this, the net work is equal to the change in kinetic energy, we know that a change in kinetic energy is positive because it's sped up. It started at rest and now it's moving. So because this is positive, that means network also has to be positive. So B is correct. Good? Next question. Keep it to yourself and your brain. Thumbs up when you have a guess. Tell your neighbor. Correct answer is E. Check it out, just in case. Okay, so 1/2 mass times speed squared. If we double that speed, we need to square the doubling part. So our new kinetic energy is equal to 4 times that, which 4 times 1/2 mass times speed squared, which is equal to 4 times our original amount of kinetic energy. Do that. Twice the speed, 4 times the kinetic energy. Up when you have a guess. Converse. Correct answer is C. Well, we know that the net work is equal to the change in kinetic energy. Change in kinetic energy is final minus initial, yes? And your final is 0. This should look vaguely familiar. And the net work, the only thing doing work in this example is friction. And is friction doing positive or negative work? Negative. Okay. So our distance is going to be equal to our negative initial kinetic energy divided by our friction. We can get rid of the negative signs. Okay with that? So if we double the speed, how many times our kinetic energy? 4 times the kinetic energy. Did friction change when the speed changed?
No.
Kinetic friction is independent of how fast you're going. So at twice the speed, you are going 4 times the distance to stop. Because you have 4 times the kinetic energy. That is not intuitive. Okay? This is what your lab should have showed you yesterday. Now, your lab yesterday had a significant amount of experimental errors. Trying to nail twice the speed, that's kind of tough to do. You okay with that? It should have been more than double. I mean, if you did, you were very off. Like you got to get close to double the speed. Okay? Hopefully it's more than double the distance. It should have been theoretically 4 times the distance. Good with that? Okay? So if you're driving through a neighborhood faster than you need to be, and a kid jumps out, if you're going twice the speed, that's 4 times the distance. Twice as far as you anticipated, because most people anticipate, oh, twice the speed, twice the distance. You just killed the kid. Okay? Is that? Okay. So, one year it snowed early, and they're like, prove it. I'm like, okay. So we did out in the parking lot, going 10 miles an hour.
When was this recorded?
A long time ago. Venture to say probably 15 years ago.
Amazing. Called Ice.
Just
How many? 15 years ago. 2010. Thought this was 2000.
I had hair once. So we're going 20 miles an hour here.
Rick? Well, he's gone.
It's right out here.
Oh. At least you can make it seem like a fun
cafeteria parking lot?
destination movie or
Yeah.
something. Don't even ask.
Okay? Good with that? So, that's the thing. Okay? So, last thing I want to leave you with, that isn't even accounting for your reaction time. Okay? So the reaction time is the time at which it takes you to go, oh, I need to stop and take your foot off the gas and put it on the brake. Okay? That's the yellow, how far you travel because of your reaction time. And then you need to add that on top of how fast you're going. Okay? And as we are proceeding into the winter months, many of you are going to be driving for the first time on non-ideal conditions.
Well, it'll probably be Tokyo drifting on the ice.
Okay? So at 30 miles an hour, normal takes you 12 meters to stop. Snow, 30. So like over twice. And ice, 66 meters. So over 5 times. Okay? Sadly, they don't have something for 60 miles an hour, just have 50 miles an hour.
Maybe we can predict.
Okay? So, on ice, it takes you roughly 400 meters to stop. Folks, that is 4 football fields. That is a quarter of a mile. So if you're going 50 miles an hour on ice and you see someone hit their brakes, you're going to hit them because you're probably closer than a quarter mile away from them.
That's why it goes slow.
Right.
Or you die. Unalived on D&D terms.
Okay. But does this make sense? Like, if it is icy out, take the T, get here alive.
And don't-
Or in one, like, your car in one piece. Does that make sense? Give yourself distance to stop. Good with that?
I don't want to see like a 30-car pileup on the bridge on I-65.
Right?
Plus, I don't want to see the bridge collapse either.